Okay, hello everybody. So in this particular lesson, we'll be talking about programming languages, specifically Java. We'll be talking about a couple of different types of variables and a couple of different types of operators. So let's get started. So first, programming languages in general. We should note that they exist at several levels. The ones that we will be working in are called high-level languages. Java is a high-level language. High-level languages are meant for humans to program in, right? They are not optimized to be running on the actual machine. So they have to go through a certain number of conversions. They first are converted into assembly language and then are converted into machine code to actually run on the program. So the thing you should just remember is Java is a high-level programming language. C++ is another high-level programming language. High-level programming languages are further divided into two categories. There are compiled languages and there are interpreted languages. Compiled languages go through a conversion, a compilation by a program called a compiler to be able to be run. Interpreted languages can be run as is. They do not need to go through compilation process. So C++, Java are compiled languages. They need to be compiled with a compiler. Python, on the other hand, is interpreted. It can be run as is, right? So there is a trade-off to these. Compiled languages, because they're compiled, tend to be more efficient, tend to be faster, use memory more efficiently, whereas interpreted languages are easier to program in. You just type your program, you can start running it. So that is the trade-off. That is. And think about where one might be good versus another, right? Okay, with that we can write our first program, and typically when you're learning a programming language you write a hello world program. This is basically a program that starts up, prints the message hello world, and it stops, right? So in our case for Java, this is the hello world program. So let's dissect it a little bit and learn a few vocabulary words, right? First, a Java program must have at least one class. It can have more than one, but it must have at least one class, right? So here the class is hello world. Secondly, the file that this class lives in must also have the same name. So in this case it must be hello world.java, Java being the extension for Java programs. Next, a class can have one or more methods inside. In this case there's only one method, which is called main, right? Methods, main is where program will start to run. And within a method you might have one or more statements. In this case there is one statement. A statement ends with a semicolon. But in this case there's only one statement. You could possibly have more than one statement. Then there are these things right here which are called comments. They exist in two forms. The // comments a whole line. And then there is the /* ending with this asterisk / that comments a whole section of the program. So these parts are stripped out when the program is being compiled. They're just meant as messages to other programs of what this part of the program does, right? The last term I would like you to learn are called blocks. Now blocks are anything that is encapsulated within curly braces. So this section here would be called a block, right? They come into play later, but that is a term that you should know and remember. Okay, so with that, let's actually write our first program and see how it works. So we'll be using IntelliJ. Let me move this down a little bit, and we'll create a new project, and we can call it anything we want. And then we say create. It's going to create an empty project. So we create a really big window, and I'm going to make it smaller. Right. So here there is no source code in here, so we'll right click and we'll say create a Java class, and we'll give it our name hello world. And it created an empty thing here. So now we'll go back and we will just paste this code in. Actually, we'll just copy this much and go back and paste it in here. Right. So, and to run it, we will just go ahead and run it, and you will see it prints hello world, right? So it started, it ran, it prints hello world. Okay, so now let's move on to the rest of the lesson. Okay, now the next term I would like you to learn is what's called a literal, right? A literal is an actual value, right? So 34 is a literal. Some string, an actual string, would be a literal, right? So right now these are numeric literals. These are numbers or decimals. These are called literals, right? Literals are, again, actual pieces of data. Right? Now the next concept you want to learn are variables. And variables are concepts within programming languages to hold data, right? These things are typed, so they hold a specific type of data. So something that is a numeric variable will not be able to hold string values, for example. These are strongly typed things. The two types that we will deal with mostly are integer and decimal, or what are called floating point types. So here they're declared. So here length is declared as an integer, and rate is declared as a double. Another term I would like you to learn is what's called an identifier. Right? The identifier is the name of a variable. So you have the concept of a variable. The name of a variable is the identifier. So in this case, int is the type, and length is the identifier or the name of this variable. Right? So variables are declared, they are initialized, and there's certain types of variables. So let's just go back to our program and create some of these. So in our hello world program, let's actually make this smaller. So we can declare certain variables, and in this case, let's say int length. Right. So we have declared a variable. If you wanted to, it's complaining because we're not really using it. We could actually use it here. It'll be happier. What is it complaining about? It'll actually give you. So it's complaining that we have not. We're using it, but it actually has no value. So that leads us to the other thing, is that we can initialize this variable to 0, right? So now it's happier, right? So let's go ahead and run this thing. Oh, this is bad syntax. Because hello world 0, we could put a little space in it to make it a little bit better. So here we have declared an integer, we have initialized it, and to a value, and then we're using it, right? Okay, let's go back. Okay, the other thing you mentioned, there are certain kinds of variables that are constants, that they can only be assigned a value once. So let's kind of use that as well. So if something was like a tax rate, so we'll have a double tax. Let's say the tax happens to be 9.5%, right? But tax rate doesn't change, and we don't want someone to reset the tax rate in our program. We can put this value called final, and that makes it a constant. That is that value can't be changed, right? So if here, and let's just make this a little bit more meaningful. Okay, and then we're printing this. Now suppose we do some mischief and go ahead and try to change the tax rate. Let's see what happens, right? So this is perfectly valid. Now it's going to give you a little warning here. It's that you can't do this, right? Now, so that is how we use constants. Okay, so let's go back. Now, a thing to note about naming conventions is that that class names are typically capitalized. Method and variable names are what's called camel case. So the first word is not capitalized and every other word is capitalized. And this is to make the variable names compact. In the previous convention, people used to use underscores to separate out the constituent words. We print underscore value underscore now, but this makes it still readable but shorter, right? And constants are in all caps. So let's see what that looks like here. Going back to our IntelliJ, you will notice that this is class is our capitalized. This will be camel case, right? So length of house, for example, if that's what we were using, or and constants are all caps. Right? Okay, going back to the lesson. The other thing we have shown is that there's certain kind of statements that we've introduced, and those are assignments, and these are of the form, the variables on the left hand side, there's an equal sign, and then there's an expression on the right. So the left hand side always has to be a variable. There can't be an expression on this side, right? And the right hand side can be an expression like a mathematical expression. All right, so we can, go back and modify our program to, add some assignments. So, for example, we can change this something to price, and let's say the price was $8, $7.05. Well, this is an integer, so it can't be like that. And then we can have an assignment where you have a double. Final is equal to, is complaining because our format's all kind of messed up, is divided by 100. So that should approximately give us the price. Let's see what it prints. So it adds tax. Hopefully this will calculate right, but it's just to illustrate use of assignments. Okay, moving on. The other thing we would like to do now is to be able to read values from from a keyboard, right? So for that we use something called a scanner class, right? It's in the package Java util and allows us to read values of different types, right? So here's an example of something being read. We initialize the scanner input stream, right? And we've created a prompt to enter a number, and then we use this method called input next int from our input to read the value, and then print out what is read, right? So here we're reading an integer, but you could also read different types of data, right? So let's actually copy that code and try to use it. We'll copy it here. Now obviously it's complaining about scanner because we haven't put in the import statement. And we'll customize it a little bit for our use. So perhaps what we will do is we will read the price, and we will calculate the price with tax, right? So we'll say enter price, and we will read it as a value, and then we will do this. We'll calculate final price, right? And then we will print the, let's see. Okay, so let's go through this a little bit. of what I have created. Let's initialize the price to 0. We have a tax rate, and we're going to hold our final price in this variable. We declare the scanner, and we prompt in and read an integer, which is the price, and then we calculate the tax, and then we print it out. So now it's entering this. So let's say we enter the number 11, and it prints out the price with tax. All right. Moving on, we have some operators available to us, which are, we just use add, subtract, multiply, and divide. Now, if you're using an integer, you have to realize that this thing will give you the quotient, right? Integer division always gives you quotient, and then you can use this percent operator, or modular operator, to give you the remainder, right? But if you have decimals, then this divide operator will do what you expect, right? There are other operators that are augmented operators that combine adding and an assignment in one shot, and they have some other operators which are called auto increment, auto decrement, that will add 1 or subtract 1. So these can be, just to show you, these can be used as follows. If you have int I is equal to 7, let's say, you can do I plus equal to 5, which is the same as I is equal to I plus 5, right? Okay. There is also I plus plus, which is the same as I is equal to I plus 1. Okay. So that's what auto, and then minus minus would be subtracting 1. All right. Now let's go to the next type of literal, which are literal, again, are actual values. So a boolean literal can have 2 different values, which is true or false. And similarly, you could have a boolean variable. Here's an example of a boolean variable called is positive. Again, this is the identifier. This is the data type, right? And you can have 2 different values. You can hold a true or you can hold a false. Right? Going back to the IDE, we can copy these things and encode. That's kind of what you can print is positive and all that good stuff. Let's see what it does. Let's see what it prints. Okay, let's just see. Oh, it's still giving me, let's see, 33, and then it prints is positive. Okay, let's see some running examples. Similarly, so then we can, just like we had arithmetic operators that we introduced, we can have relational operators. And relational operators compare 2 values, and they return a boolean, right? So they can compare if something's less than equal to, greater than equal to, or not equal to, right? So here are some examples of what those expressions would look like, and these things always return a boolean expression, right? A boolean expressions always return true or false, right? Arithmetic operators will always return a numeric values, and boolean relational operators will can be used to create boolean expressions, which will always return a boolean value, right? So let's see it in action real quick. And we can also do something. We can reuse our I. So say is I positive, and then here say I greater than 0, right? And here I is set to 7, and let's erase. after you do all of this, it's going to have 5 plus 7 and 7 plus 6, which will be 13. So, right, before to enter. So it's true. Now, if you made it negative 77, which could not possibly hold, could not possibly be positive after all this, so it's false. Okay, so now going back again, we have introduced a concept of high-level languages that are compiled. We've written a hello world program. We have learned about boolean and numeric variables. We have learned about reading values from the screen, from the keyboard, and then we have learned about relational and arithmetic operators. Right? Okay, see you in the next lesson.